Hello. Today we are going to start with the second lecture of the first unit, that is Theodolite surveying. Here in this chapter we will be studying fundamental axis and its relationships. What is fundamental axis is of the theodolite. Okay, now we are just trying to understand what is theodolite, what are its components, what are the terms used in the theodolite surveying. Okay, and we are trying to identify what are the important things that we have to do while we are, what are the procedures that are to be done during the working with the theodolite. So when we go for the reading, how to read the values, how this is all is done, we'll have to do it in a video which will be shared in a lab. Okay, if you get into the lab, you will get a video where we will be doing the getting the knowledge about how to get how do we get the observations and the values accurately, right? So today here we are going to study the fundamental lines. So what are these fundamental lines and what are their relationships? Okay, how they are related to each other, that we're going to study. Next is temporary adjustments. So these adjustments are nothing but the small adjustments are to be done before we start to read or start using the theodolite. So what are those and how they are affected? If you don't do that, how what are these consequences, right? So we'll study it all together today in this class. Fundamental axis and their relation. So these are the components that we have studied about the theodolite, but this is been shown in a different staged manner. This has been opened up and it is shown, right? You can see a vertical axis here, right? You can see a vertical axis, right? This is a vertical axis. The pink color line which you can see is a vertical axis, right? Next is your horizontal axis. You can see horizontal axis, right? This is a horizontal axis which is perpendicular to the horizontal axis is perpendicular to the vertical axis, right? Then your line of sight, a line of collimation, you can say, right? One of the same, right? It is perpendicular to the vertical axis. Now we have remembered 3 points. This is a vertical axis, this is a transverse or the horizontal axis which is perpendicular to the vertical axis. Line of sight, right? Line of sight is perpendicular. Line of collimation or line of sight is perpendicular to the vertical axis itself, right? Then the axis of vertical altitude bubble, you can see this altitude bubble, right? You can see this altitude bubble, right? Its axis is parallel, right, with respect to line of sight. Can you see this? This line and this line are parallel. So line of sight and the axis of altitude bubble, not the plate bubble, it is the altitude bubble, they are both parallel to each other, right? And can you see this plate, right? You can see this plate, right? So this plate is perpendicular to this vertical axis. So what we have studied today, what we have here, that is there is a vertical axis to which there is a horizontal axis, it is making a 90 degree to it, right? Then you have line of collimation, right? This is your HA, this is your VA, right? This is your line of collimation, right? This is perpendicular to the horizontal axis, making 90 degrees like this, right? Next to this, there is one more line where a line of collimation and altitude bubble is parallel, right? These are the things you have studied. One more thing is the plate axis, okay, is perpendicular, right? It's perpendicular to the plate axis is perpendicular, plate axis is perpendicular vertical axis. So one thing you have to remember, that horizontal axis is perpendicular to the vertical axis, and the line of collimation is perpendicular to the horizontal axis, and to the line of collimation a line is parallel. Which line is parallel? The axis of the altitude bubble, right? This is how the image will be. I will try to show you once more, right? This is your vertical axis. Through that you have a horizontal axis which is perpendicular. Now at the center of it, you'll be having a line of collimation or line of sight which is perpendicular to the HA, right? For this, it is the altitude bubble is parallel to line of collimation is and also perpendicular to horizontal axis. This can be asked. It is also perpendicular to the horizontal axis. As the line of collimation is perpendicular to the horizontal axis, same way your altitude level bubble level axis will be perpendicular to the horizontal axis. One more thing you have to keep in mind is the bottom plate that you have studied, the level heads, right? The leveling heads. These are perpendicular to the vertical axis. These are the 1, 2, 3 and the bottom 4, right? That is your plate level axis, right? So these 4 are the fundamental lines. 5 with including the vertical axis. 5 are your fundamental lines and their relations. You have to keep in the mind, and you have to draw the diagram the same way I have drawn here. This is a rough diagram, but in the notes you will get a correct diagram through which you will get understand. This is for a reference to understand visually. So not this diagram, another diagram, line diagram will be there that you are going to draw. So with this diagram you have to name those and show the angle between them, what angles are they are, right? And show the relation, which is we have to write which line is perpendicular to which line or parallel to which line. So when you write this, you will get around, this question will be asked for around 5 to 10 marks. Sometimes it is asked for 10 marks, sometimes it is asked for 5 marks. So this is very important point. Just remember the relations, very easy, and the diagram. If you remember the relation, it becomes very easy. So which are the fundamental lines? Vertical axis, horizontal axis, or Trinian axis, or transit axis, or you can call it as a transverse axis also. These are the names for the horizontal axis, by whichever name they might call it. Okay, line of sight or line of collimation, axis of altitude level tube or bubble tube, axis of plate level, right? These are the 5 fundamental axis line. So this is what I was talking about. The axis of the plate must be perpendicular to the vertical axis, right? The horizontal axis must be perpendicular to vertical axis, Line of collimation must be perpendicular to the horizontal axis, and the axis of altitude level must be parallel to the line of collimations. If these axes are not as per the given below, then your theodolite will not work or not serve the purpose, because if these axes are not perpendicular to each other, we will not get the accurate results that we require, because the whole of the functioning of theodolite is dependent on the this fundamental axes. Without proper fixing of these fundamental axes, you can't you can't get accurate or precise results. Your values or the readings or the observations that you do will have errors in it. Okay, so for that it becomes very important. Next is temporary adjustments, but you only have a temporary adjustment. Before we get into before we start with the temporary adjustments, we would like to tell you about types of adjustments and what is actually adjustment is. Adjustment is nothing but simple minor adjustments that are required to obtain accurate readings, right? That is what adjustments are done before taking the readings itself, right? There are two types. One is the permanent adjustments, other is the temporary adjustments. Now what is the difference between the temporary and the permanent adjustments? So if you see, we talked about the fundamental axis or the lines, right? If there is any problem or any adjustment required in the fundamental relations, right, then that adjustment is called as permanent adjustments. The whatever adjustments we do in the permanent adjustments are with related to the fundamental lines of the theodolite. Okay, if they are not 90 degrees, they are not parallel to each other, so these things are being taken into consideration in the permanent adjustments. In the case of temporary adjustments, we will be studying the every time. So in the temporary adjustment, we will be studying whenever you set up an instrument, what are the things that you have to do to get the accurate results, right? These are to be done whenever you shift the instrument to a new station or a new point, okay, by dislocating the station point from one point to the another point. Every time when you change the station point, you have to do this temporary adjustments, right? So these are the adjustments which are done before making the observations at every step up of the instrument. The They consist of setting up of theodolite, leveling, focusing of the eyepiece, and objective. Now, what he is telling, right? Setting up of the theodolite, leveling it, focusing of the eyepiece. What is object glass? So, objective. I have told you what is eyepiece, through which you observe, through you look, and the another part of your glass or a telescope is called as object glass, where you have to see the object, right? Eyepiece, you have to see through the eye, the piece through glass piece, which you see the object from the another point. That point is called the object glass. So these terms and the parts will help you to understand the basics. So that was being taught in the first lecture, right? Temporary adjustment of vernier theodolite consists of following operations. So what are the temporary adjustments now? First one is setting up of this theodolite. Next is centering. Third is leveling. Fourth is focusing. Now, coming up to setting up the theodolite. Setting up of operations consists of fixing the theodolite with the tripod stand along with the approximate leveling and centering over the stations. So what is trying to say? First thing is you have to bring the theodolite and set over the tripod stand. You might have seen the tripod stand in the content box, right? This is your tripod stand. I'll show you. This will be a three-legged tripod stand like this. Okay, over which your theodolite is been set up. Okay, you have to set up it up. Once you set it up, right? Right. You have to turn these legs either to right or left, all the three, such that the level heads. This at here there will be level head, right? There are plates, right? These plates are parallel to the ground, means they are level to the ground, right? That is what is the first thing, leveling approximately, right? By the eye judgment you are going to level it by pushing the legs left or right of your sides so that they become leveled, right? First thing is you to fix the theodolite over the tripod stand, then move the legs such that they come approximately level to the ground, right? Next is approximately looking at the, if this is a station point, you have to make the center of the tripod to be over the station point, such a way that it not might be exactly over the station point, but approximately bring it over the station point such that it might be nearer to the center of it, right? Next temporary adjustment is centering. So where there will be understanding how exact centering is to be done. Here you're going to just set it up properly and level it and center it approximately. Okay. So for setting up the instrument, tripod is placed over the stations with the legs widely spread so that the center of the tripod head lies above the station and its head is approximately leveled. And the height of the instrument should be such that the observer can see through the telescope conveniently. The height should be such that the observer, the who is taking the readings, shall be able to see the readings properly. The height should not be very high or too low, so that it makes you uncomfortable while taking the readings. That you have to keep in the mind. So this fourth point will be understanding in the next adjustment, that is centering. The operation involved in placing the vertical axis of the instrument exactly over the station mark is known as centering. So this is what is your tripod legs are, that is tripod, right? Three leg tripods. Can you see this? This with a thread here, which is been attached to the center of the tripod. So with the help of this plumb bob, that the thread with a solid at the bob at the end, right? So which is vertically being hanging over here, right, is made to hang such that it free falls from the top, so that it will show the verticality of the station point and where it is been there. So once you set this tripod with theodolite, we will be putting the plumb bob here, and once you put the plumb bob, we will check whether the plumb bob is exactly over the station point or not, right? Because the plumb bob is percolating downwards, right? So the what are we doing imaginarily? Now we are going to do it with the help of the plumb bob, right? So when you free fall the plumb bob, and we will see whether the plumb bob is exactly over the station point, bisecting the station point. If it is not bisecting, we have to just push this legs to the left or the right and check whether the plumb bob is coming at the center of the station point or not. By try and error method, we have to bring this plumb bob to the center of the station. If you bring the plumb bob to the center of the station point, that means your vertical axis of the theodolite is also at the center of the station point, is properly verticality is been maintained. So that is what we are going to do here, right? Can you see there is an object kept here, right? Okay, and if you have a plummet, an optical plummet, there is a small glass provided through which you can see through the theodolite, and you will be able to see like this what is visible through the optical plummet. So there is a crosshair, right? At center of the crosshair, the station point should become. It should bisect the station point at the center of the crosshair, right? So that means your vertical axis is properly bisecting the station center of the station point. So with the help of the plumb bob or with the help of the optical plummet, depending upon the model of the theodolite, the higher versions of the theodolite has the optical plummet. If it is the older, you have to go through the help of the plumb bob. You have to center it, right? So whatever I have told you here is been told here, right? This all are try and error methods. It is not that you will get exact values in the first time itself. You have to adjust this 2 or 3 times and try to bring it. Then only you will understand. Then only you will get the center of it. It is not that in one go you will get the station point bisecting the center of the axis, or the you bring the theodolite station central. So it is not possible. By try and error method, you are going to do this. Next is the leveling, right? Loosening the upper clamp screws, and turn the upper plate. Okay, turn the upper plate of the plate level, right? What we're going to do is, first you're going to loosen the screws, right? You're going to loosen the screws first. Once you loosen these 3 screws, you're going to turn this such a way that this bubble tube is parallel to the, see, this is bubble tube, right? This is the axis of the bubble tube, and this is the axis of the these 2 foot screws, right? So first you're going to open the foot screws and turn it such a way that the axis of the bubble tube and the axis of the 2 foot screws are parallel to each other. You can see here they are parallel to each other, right? Right, they are parallel to each other. So when you bring two foot screws parallel to the bubble tube, then the parallel foot screws are to be rotated either in the anti-clockwise or clockwise directions. Both are to be turned, right? If you are trying to do clockwise turning of the foot screws like this, both simultaneously at a time, you have to hold the screws and turn it clockwise or anti-clockwise, right? Turn either clockwise or anti-clockwise. Both should be turned in the same direction, such that this bubble tube comes at the center of the tube. The bubble should, you have to turn the foot screws till your bubble comes to the center of the this tube. I can see in this image, right? Right? Can you see this? That the bubble, this bubble is at the center now. Once you turn clockwise, both these screws are turned clockwise, then you are going to, what you are going to do is, you are going to turn the foot screws either clockwise or anti-clockwise simultaneously till your bubble comes to the center of the bubble tube, right? Next, what you are going to do is, again, then you are going to turn the plate level such that your the bubble tube is perpendicular to the two foot screws which was previously used, right? You have 3 foot screws. If suppose the first 2 screws that we have used is 1 or 2 or AB, so at that time it was parallel to each other. Now they should be perpendicular to each other, right? Now in the second case, the bubble tube should be perpendicular to the previously used foot screws. When you are used, right? So to turn clockwise and anti-clockwise simultaneously, you have used 2 foot screws. It was parallel to it. Now it has to be perpendicular to it. Once it is perpendicular to it, the other foot screw which was not been used previously, that foot screw is to be turned single foot screw which was not used, the third one, right? The third foot screw is to be used to turn clockwise or anti-clockwise till the bubble comes to the center of the bubble tube again, right? In this case also the same thing. This screw is to be used for clockwise or anti-clockwise turning of the screws till your bubble comes to the center of the tube, right? This is to be done till you get once you're done with this procedure, just try to turn the telescope or the theodolite and check whether the bubble tube comes to the center or not by changing its position. By changing the position of the theodolite, by turning it, right, rotating it, we will come to know whether the tube is at the center. If it is at center, then your leveling is been done. If not, repeat the procedure one step 2 again till you get the theodolite leveled, right? This is what was explained, what I have told. This is in all written. Next is focusing. So focusing is nothing but there is a focusing screw, right? If this is a theodolite, I will try to explain you here only itself. If this is your theodolite, you have an eyepiece here. Here you have object glass, right? This is a O, this is a E, to which you're going to look here like this, right? Right. So at the center of the eyepiece, at the left side to the right side of your telescope, you have a screw, right? With the help of the screw, when you turn this screw clockwise or anti-clockwise, you will get the clarity of the image. Depending upon the distance of the object, the focusing has to be done so that the image, right, the image falls on the lens properly. If the image is doesn't falls properly on the lens, that is at the diaphragm, then the image becomes blur, right? So with the help of the object focusing screw, you're going to turn it so that the image becomes clear, right? It becomes blur and you are not able to see the image properly. So that time you're going to use the focusing screw, right, for the proper clarity of the image, right? Your crosshairs are being visible but the image is blur, so for that you are going to use the focusing screw. And here we are talking about the focusing of the eyepiece, right? So the eyepiece is here, it can be also moved, right? Whenever you are not able to see the crosshairs on the your lens, when you see through the telescope, you'll see the crosshairs. If those crosshairs are not visible, then you are going to turn your eyepiece clockwise or anti-clockwise, right? This eyepiece, you're going to turn it clockwise or anti-clockwise, right? So that you can get a clear and distinct image of the crosshair. You're going to move it in or out until your crosshair appears clear and distinctive, right? These are the two focusings that we're going to see in the focusing temporary adjustment. Every time when you bisect the new object, you have to focus it so that you get a proper image is formed over the lens and you can see the accurate or the clear image, right? If you are not able to see the crosshair, you're going to turn the eyepiece to get a clear distinct image of crosshair, right? This is what I have explained you. This is all is in writing, right? This is for today. We have completed the second lecture of your first unit, that is on the temporary adjustment and the relations of the fundamental axes. Thank you.